Alright, so on this, it says graph the inverse of this function, include the line of symmetry. So let's think about what this function looks like first. So the vertex is going to be -4, -3, and my a value is 2. So 1, 2, 3, 4, 1, 2, 3. Okay, so there is my vertex, and then my a value is over 1 up 2, and then over 2, not up 4 but up 8. 1, 2, 3, 4, 5, 6, 7, 8, and then likewise over 1 up 2, and then over 2 up 8, and I think we might be able to get 9 in here. So over 3, no, that's 9's not going to work either. Okay, so this is my graph. Let's try that again. Alright, so there's my, and they wanted us to include the axis of symmetry, which is right here. And that's my axis of symmetry. Alright, so is the inverse a function? And so we would say is the inverse a function, and we would say no, it is not a function. Because what we do is, to get the inverse, we switch the x and y values. So I have these coordinates graphed, just graphing it. So let's start here. This is -6, 5, and then I had -5, -1, and then I have -4, -3, the vertex, and then I had -3, -1, and then the last point I have is -2, 5. Alright, so the deal is, this is my, this is d of x, right? That's d of x. So if I want the inverse of this, what I have to do is simply, let me use a different color so we know we're talking something different. I just have to switch. So this would be 5, -6, -1, -5, -3, -4, -1, -3, and 5, -2. So now if I graph these, 5, -6 is here. -1, -5 is here. -3, -4 is right here. And -1, -3, and then 5, -2. Oh, wait a second, I think I missed one. -1, -5. Oh, that's what I did wrong. That point's wrong. So -1, -5 is here. And -1, -3 is here. Alright, so there we go. So now here's my graph. This is the inverse. So now, is the inverse a function? So no. And why isn't it? So when I do the vertical line test, notice what happens is, for one input I get 2 outputs. So that is not a function. Now, if I restrict the domain, so if I restrict it to only half of it, then I could make it a function, but in this case it is not. So the domain and the range of the inverse is x is greater than or equal to -3, and the range is all real numbers. So what I want you to realize, and I guess I need to also include the axis of symmetry, is that when we do the inverse of this quadratic, if we want to make it a function, we have to restrict the domain. So when we create the inverse, it's not a function. So you might want to say something here to make it a function. The domain needs to be restricted.